One shortcut that we can use to prove that two triangles are similar to each other is called AA similarity, or in other words, if we can prove that just two angles of two triangles are congruent, we can prove that the two triangles are similar to each other. So let's take a look at these two triangles at the bottom. I can see one pair of angles is already matched up. We have the right angles matched up. However, that only gets us a single A. I need at least two angles matched up to say that they are similar to each other. Well, I can see that obviously 26 and 64 degrees are not the same. However, knowing that the sum of the angles in any triangle is 180 degrees, I can figure out what the missing angle in either triangle is. So subtracting 90 and 26 from 180, I can learn that angle E is 64 degrees. Aha, those match up. Similarly, no pun intended, I can figure out that angle K is 26 degrees. And so that I can see that, yeah, in fact, I have two angles matched up. And as it turns out, if two angles match up, the third one has to match up automatically. So yes, I get two angles. In fact, I get all three. It only takes two though. So to answer their question, are the two triangles similar? Yes, they are. My reason is going to be what shortcut I used. I'm going to say, yes, these are similar because of angle. I have two angles matched up. The final part of this is they want us to write a similarity statement. So what I'll do is I'm going to say triangle, and let's do the first one in alphabetical order. So triangle CDE is similar to, that's just the little squiggle, triangle, and now the second one needs to match up to the first one. Angle C was our 26-degree angle, so that has to match up to angle K. Angle D was our 90 degrees, so that has to match up to angle G. And then finally we'll finish with H. So there's our similarity statement. Same question for these problems. Let's see if we can prove the two triangles are similar to each other. The only shortcut we have at this point is angle. So I want to see if there's two angles I can match up to prove the triangle's similar. Well, in this first diagram, the overlapping triangles, I can see that I have one angle matched up. Obviously, angle ABE and angle ACD are congruent. They're both 52-degree angles. However, that's only one pair of angles. I'll need a second one that I can find out is congruent as well. And remember from the last unit, we're allowed to add tick marks, but only if we have a good reason to. I can't just add them because I want to. Well, what you may notice about these two overlapping triangles, this little one on top, and then this full one down here, they have something in common. They both share this angle A. Because of the reflexive property, I know that angle A is congruent to itself. We talked about that briefly in the last unit, but I know angle A will be congruent to itself because of the reflexive property. And so there are the two angles that I need. So can I conclude these two triangles are similar? Yes. My reason is going to be because of AA. I have two angles matched up. In our next diagram, there are no tick marks given to me, but remember, we are allowed to add some as long as we have a good reason to. Well, you may recall vertical angles are angles that are across from each other, and they're congruent. So there's one set of congruent angles. These little triangles mean two lines are parallel, and with parallel lines, again, recalling things from the last unit, I recall that alternate interior angles are also congruent to each other. Angle R and angle T would be another example of alternate interior angles, but remember, I only need two, although if I have two, I'll always have three. So yes, these two triangles are also similar because of angle. You may notice we're kind of writing little informal proofs. We're not writing down everything, we're just more talking about it, but we could certainly make this more formal if we wanted to write a two-column proof. Our last example, are these two triangles similar to each other? I hope the obvious answer is no. We can see that one triangle is definitely distorted from the other one. There is something they have in common though. Like our first example on the screen, they both share angle Y. Because of the reflexive property, they both have that angle in common. However, as soon as I look right here, I can see that those angles are definitely not congruent to each other. And to be similar, I need angles that are congruent. Otherwise, they're going to be distorted. And so because those angles are not congruent, these two triangles are definitely not similar to each other.